Hello everyone, Chapter 11, Circumference, Area, and Volume, Section 11.1, Circumference and Arc Length. So let's start off with example 1. Find each indicated measure. So we want to find the circumference of the circle given that the radius is 11 inches. So if the radius is 11 inches, the diameter is 22 inches, and the circumference is equal to 22 pi inches. We want to find the radius of the circle if the circumference is 4 millimeters. So this time we're working backwards. C equals 2 pi r. This time we know the circumference is 4 equals 2 pi r. Divide both sides by 2 pi. 2 pi's cancel on the right. R is equal to, and 2 cancels with 4, 2 over pi millimeters. There's the answer to example 1, part B. Example 2, part A, find each indicated measure. We want to find the arc length of arc PR. So we need to know that this radius, and I know it's a little hard to show up, my printer was running low on ink. This says 12 inches for the radius and 100 degrees for the arc. What is this fraction of the circle? 100 degrees, arc length, of PR is equal to the fraction that PR is of the entire circumference, and that's going to be 100 over 360, we'll reduce that in a minute, times the circumference of the circle, which is 2 pi times 12. So 100 over 360, 10 over 36, 5 over 18, times 24 pi. 18 and 24 both reduce by 6, 3, 4, 20 pi over 3 inches. Let's go to our calculator, get an approximation for that. And approximately 20 times, we'll always use your pi key on the calculator. Don't just round to 3.14, use the entire pi key. Divided by 3, it's going to be something a little bit more than 20. So 20.9 inches. On the quiz or test, I will tell you whether I want the exact in terms of pi or rounded to the nearest tenth or whatever. Part B, we want to find the entire circumference of this circle. This is 130 degrees. I know it's a little light, and 6.5 meters is the arc length of QR. So again, we can still use this formula to find the circumference. So arc length of QR is equal to 130 over 360 times circumference. Arc length is 6.5 equals, 13 over 36. C. Multiply both sides by 36 over 13. C is going to equal approximately 36 times 6.5 divided by 13 equals exactly 18 meters. Change that to an equals. There's part B. Part C, we're going to find the measure of the arc in degrees. So we have 21 meters is the arc length, 14.32 meters is the radius. We're looking for the degrees. Okay, what fraction of the circle is it? So arc length of, just kidding, JK arc is equal to measure of arc JK over 360 times circumference, or 2 pi r, which is 14.32. The arc length is 21 equals measure of arc JK over 360 times 14.32, it's going to be 28.64 pi multiply both sides by 360, divide both sides by 28.64 pi. The measure of arc JK is equal to 21 times 360 divided by 28.64 and divided by pi. So 21 times 360 divided by 28.64 and divided by, hit the pi key again, equals measure of arc JK is equal to 84.0 degrees. There's the answer to part C. Example 3. The radius of a wheel of a toy truck is 4 inches. To the nearest foot, how far does the wheel travel when it makes 7 revolutions? To that, let's take a look at a circle making 1 revolution. Okay, so here's our circle. If that circle makes 1 revolution, how far has it traveled? So let's take a look at some white paper here. So imagine here's our circle, and we start right here where it's touching the paper, and we make 1 complete revolution. How far has it traveled when the pencil gets back to the paper again? Well, this wheel rotating, as it rotates, it's traveling 1 revolution is equal to the circumference. Exactly. So, go back to our problem. How far does it travel when it goes 7 revolutions? That's 7 times the circumference. That's all it's asking. So to the nearest foot, how far does the wheel travel when it makes 7 revolutions? Well, 1 circumference equals 2 pi r. Circumference equals 2 pi times 4. Right? Our truck wheel is 4 inches. So circumference is equal to 8 pi. But we want to make 7 of these revolutions. So we're going to multiply both sides by 7. So now we have 56 pi. That's inches. And we'll round that to the nearest foot. So approximately equal to 56 times, we use our pi key, 175.9, or our final answer is 176 inches. When it's gone 7 revolutions, it's traveled about 176 inches, rounded to the nearest foot. All right, example 4. A path is built around 4 congruent circular fields. The radius of each field is 100 feet. That's the radius of each of the fields. How long is the path? That's a good question. So this is 100. That's another 100. So this is 200 feet. 200 feet. 200 feet. 200 feet. What do we have left? The rounded corners. This is 90 degrees. 90 degrees is 1/4 of the circle. 90 degrees is 1/4 of 360 degrees. So this is 1/4 of the circle. Another fourth, another fourth, another fourth. So in other words, these 4 rounded pieces come together to make one full circle. Circumference of that full circle, 2 pi r. Circumference equals 2 pi times 100. Circumference equals 200 pi. So the perimeter is equal to 200 pi plus 200, 400, 600, 800 feet. So our final answer, so we want to round it to the nearest 100 feet. So 200 times pi plus 800 is going to equal 1,400. Let's round it, go approximate. I'll round in a second. Approximately 1,428.3 feet. We're rounding to the nearest 100 feet, not to the nearest foot, not to the nearest 100th of a foot, not to the nearest 10 feet, to the nearest 100 feet. So 1,428 rounds down, because 28 is lower than 50, to 1,400 feet. That's our answer to example 4. Okay, now this is a little bit of history of why do we have 360 degrees in a circle. There's a few theories. The one that I like most is because 360 is evenly divisible by a lot of different numbers, but there's some other theories that are in here. What you're going to be seeing now is a different way of measuring an angle. So degrees are used for measuring angles. Feet are used for measuring distance. Well, other than feet, we also have centimeters, which are used for measuring distance. We have the metric system, we have the English system. So there's 2 different ways of measuring lengths, and we're okay with that. There are 2 different ways of measuring angles. One is the one that's most commonly used, that you are most aware of, and that's degrees. Another one is called radians. Now radians are, you're going to have to write out the definition. Radian can be converted, just like we can convert inches into meters and meters back into feet. We can convert radians into degrees and degrees into radians. Okay? If we're going from degrees to radians, we're going to multiply by pi over 180. If we're going from radians into degrees, we're going to multiply by the reciprocal of that, 180 over pi. So we're going to convert 30 degrees to radians. So we're going from degrees to radians. From degrees to radians. So 30 times, from degrees to radians, pi over 180. 30 and 180 reduce. 3 goes into 18 6 times. So we get pi over 6 radians. There's example 5a. 5b, we're going from radians back to degrees. Okay? We're going to multiply by 180 over pi. So 3 pi over 8 times 180 over pi. Pi's cancel. 8 and 180 reduce. They both reduce by 2, 4. 180 doesn't divide by 8, but it does divide by 4. And that gives me 45. So this is going to be 2, 45. 45 times 3 is 135 divided by 2, so we get 135 over 2, which is equal to 67.5 degrees now. We went from radians back to degrees. Okay. Example 6. What is the radius of circle O? The radius of circle O is 3 times the radius of circle R. Sorry. What is the circumference of the diameter of each? What is the ratio of circumference to diameter of each circle? Okay. So ratio of circumference to diameter for each circle. So the circle O, radius, circumference equals 2 pi, d pi. Okay, that's for the first circle, circle O. If the circle R, circle O is 3 times the radius of circle R. The ratio of the diameter to circumference. So circumference to diameter, divide both sides by d, is equal to pi. Okay, that's for circle O. Circle R, is smaller. So let's do. This has a radius of R, then this has a radius of R over 3. So C is equal to 2 pi times R over 3. Okay? And I want to find what the ratio of the circumference to the diameter is. Well, the diameter of this circle, circumference equals 2r thirds times pi. This is our diameter, right? So our going to divide both sides. So C over 2r thirds is equal to pi. It's a long way of saying no matter what, the ratio of circumference to diameter of any circle is always equal to pi. Compare the circumferences of the two circles. So now we want to take a look. The circumference of the first circle, circle O, is equal to 2 pi r, circle O, circle R, capital R. Circumference of circle R, we found a minute ago, was 2r thirds pi. What's the difference between these? Well, this circumference is 3 times this circumference is 3 times the size of this circumference. This one is 1/3 the size of this circumference. So if the radius is 3 times as big, then the circumference is 3 times as big. So compare the circumferences. They are in a 3:1 ratio. Find length of arc ADB. So that's going to be this direction here, the major arc over here, in terms of pi. So if this is 150 degrees, then 360 minus 150 is going to be 210 degrees. And what fraction of the circle is that? It's going to be 210 over 360. So length. Length of arc ADB is equal to fraction of the circle, 210 over 360, times the circumference, 2 pi times the radius is 18 centimeters. 21 over 360 reduces down to 21 over 36, and that reduces by another 3, 7 over, so 7/12 times 36 pi. I should have left it as a 36. That's right. 12 goes into 36 3 times. We end up with 21 pi centimeters. And it asked us to leave this in terms of pi. So 21 pi centimeters is the answer to example 7. Example 8. The two circles shown below are concentric. That means they have the same center, different radii, but same center. Name two arcs that have the same measure. So that they have the same measure, not the same length, same measure. We have a variety of choices that we can choose. The measure of arc FE is going to be equal to the measure of arc BD. They're both going to be 70 degrees. Okay? The measure of arc GF is going to be equal to the measure of arc AB. They're both going to be 110 degrees. It didn't ask us to find the measure of the arcs, just measure of two arcs that are the same. And of course we could, if we had a third letter here and a third letter here, we could measure these two semicircles, or arc ABD, 180 degrees, is the same as arc GFE, 180 degrees. Okay. Example 9. So in 5 minutes, the tip of the minute hand of Boston's Custom House Tower, you can see this in Boston, it's a famous landmark in the city of Boston, travels 6 feet and 10 inches. So as it goes around the clock face, as it goes around the circle, and we're talking the minute hand, that's the longer of the two. That's the longer of the two hands. When it goes 5 minutes from the 12 to the 1, or from the 1 to the 2, it travels 6 feet, 10 inches. So let's take a look now at the clock face. As it goes from the 10 to the 1, this is 6 feet, 10 inches. What we want to know is what's the length of the hand, the minute hand. And really, what is that asking? It's asking what's the radius of this circle. Okay, so to answer that, let's go to our arc length formula. So arc length equals arc measure over 360 times circumference, which 2 pi r. Since we're looking for the radius, we're going to use 2 pi r. Okay, so we have to figure out what the arc measure is. We know what the arc length is, and we're going to have to solve for r. I'm going to do a little reducing first. 2 reduces the 360 down to a 180. Okay, if this is 5 minutes, 5 minutes from 12 to 1, the 1 to the 2, the 2 to 3, it's 5 minutes. How many of those are there? There are 12 of them. There are 12 5 minutes in an hour. 12 times 5 is 60. Okay, so if we take 360 degrees and divide that by 12, so 360 divided by 12 is 30 degrees. So this is a 30-degree arc. Now we have arc length, 6 feet 10 inches. 10 inches, 6 feet 10 twelfths, or 6 feet 5 sixths, or 41 sixths. I'm going to leave it as an improper fraction because if I do the division, I'm going to get a decimal that I don't like as much. Yeah. So it's going to be a repeating decimal. So we're going to leave it as 41 sixths. Okay, so 41 sixths equals 30 degrees over 180 times pi r. Remember, we reduced the 2 and the 360. 30 and 180 can reduce to 1/6, so 41 sixths equals pi r over 6. Multiply both sides by 6. 41 equals pi r. Divide both sides by pi. R, the radius of the length of the hand, the minute hand, is going to be 41 divided by pi, approximately, I'm going to round this off, and it's asking, it doesn't say what to round it to, but approximately 13 feet. So it might not look like it, but if you're looking at the hand on this clock, it's about 13 feet long out to the tip. From the center of the clock out to the tip of the hand is about 13 feet. Example 9. Example 10. Find the perimeter of the shaded portion of the figure. Leave your answer in terms of pi. Explain your reasoning and state what assumptions you make. So again, because my printer's running low on ink, the shaded portion is in here. Okay, so we want to find the perimeter of the shaded portion. So we are going to make some small assumptions. They're not huge, some small ones. This is a right angle here. So we're going to assume that's a right angle, that's a right angle, that's a right angle, and that's a right angle. Okay, so that's our first assumption that we're going to make. So that makes this 1/4 of a circle, 1/4 of a circle, 1/4 of a circle, 1/4 of a circle. So the perimeter of the shaded region is really just it's really just the perimeter, the circumference of one circle. Okay, so let's let's say if this is 4 inches, that was the 4 inches from here to here, I think it is. So 4 inches is the whole side of the square. Okay, so the 4 inches is the entire side of the square, which means that the radius, so 1, 2, 3, 4, so we have a radius of 1 inch. So circumference equals 2 pi r. Circumference is equal to 2 pi inches, and it asks to leave it in terms of pi. So there's example 10, 2 pi inches. Okay, so our assumptions were that's a right angle, and that 4 inches referred to the entire side of the square, which I'm almost positive it does. Example 11. An athletic field is a rectangle, 100 yards by 40 yards, with 2 semicircles at each end, okay, for the short sides of the track. This is a semicircle, this is a semicircle. This, not so short. Interesting question if it is or not. A running track 10 yards wide surrounds the field. Find the perimeter of the outside of the running track to the nearest 10th of a yard. So we want to find the length from here to here, here to here, and circumference of this circle here. Okay, so this is 100 and 100. That's easy. So that's 200 that we're adding. What's the circumference of this circle? Well, what's the radius of this circle? The radius of this circle is not 40, it's 50 yards. Or diameter, I'm sorry, it's not radius of 50 yards. Sorry. This is 20 plus 10, so radius of 30 yards. A diameter of 60 yards. 10 plus 40 plus 10. So circumference equals diameter pi. Circumference equals 60 pi. We're going to add to that 200. So the perimeter equals 60 pi plus 200. 60 times pi key plus 200, and we're rounding this to the nearest tenth. So approximately 388.5 yards. Okay. Example 12. Amy is constructing a curved path through her rectangular yard. She will edge the 2 sides of the curved path with the plastic edging. Find the total length in meters of the plastic edging that she's going to need, and show you where to explain how to find the total. So we're going to make some assumptions here. Right angle. Right angle. Okay. This is a quarter of a circle. This is another quarter of that same circle with a radius of 4 meters. So circumference of a circle, 2 pi r. Circumference equals 2 pi times 4. Circumference equals 8 pi. But we only want half of this circle. We don't want the full circle. So we're going to deal with half of that 4 pi meters for this part of the edging. We still have to deal with this quarter of a circle and this quarter of a circle. So we have another circle here equal to 2 pi r. So circle 1, circle 2. Circle 2 is equal to 2 pi times, this time the radius is 4 plus 2, or 6 meters. 6 meters. Circle 2 is equal to 12 pi. Again, we only need half of that. We have 2 quarters, or 1/2. So 6 pi meters. Total, find the total length in meters of the edging that she's going to need. She's going to need 10 pi meters, or approximately 31.4 meters of edging. All right, example 13. So I have 2 different pictures here to help explain this next problem, example 13. So Reno, Nevada is approximately due north of Los Angeles. So if we look at our map here, here's Reno, here's LA, and it's pretty close to being due north. It's not exactly, but it's pretty close to being due north, which means that they're almost exactly on the same line of longitude, which runs from the North Pole to the South Pole. Okay. Difference is Reno is sitting at 40 degrees north. That means its latitude, the circle that goes around parallel to the equator, is 40 degrees above the equator. Okay? Whereas LA is 34 degrees above the equator. So what we need is this angle here, which is 6 degrees. 40 degrees minus 34 degrees, giving us 6 degrees. So it's 6 degrees between LA and Reno. Okay? If the radius of the Earth is approximately 6,400 kilometers, which it is, find the north-south distance between the 2 cities. We want to know what's that length. Now, it's not a straight line going through the Earth because the Earth is curved. So it's actually arc length. It's the length of the arc around the circumference of the Earth. So arc length equals arc measure 60 over 360, the fraction of the Earth that we're measuring, times circumference 2 pi, and our radius is 6,400 kilometers. Okay? Arc length, or distance between the 2 cities. Arc length equals 6 times 2 is 12. 12 goes into 360 30 times. So we have 6,400 pi over 30. 64 does not divide by 30. 623 is approximately, not approximately, let's do it exact, 213 1/3 pi. Do we want to round to, doesn't say, find the distance between the two, so we don't need, doesn't say what to round to. 213 1/3 times, hit our pi key. We're going to get approximately, let's round it to the nearest kilometer, 670 kilometers between Reno and LA. And if you use Google Maps, Google Earth, it's going to confirm that. All right, example 14. Using the same process, we're going to find these three distances. So find the distance in kilometers between each of the following pairs of cities whose latitudes are given. Assume the cities are on the north-south line and that the radius of the Earth is 6,400 kilometers. So again, Madison, South Dakota is almost due north of Dallas, Texas. So the difference between them, arc length, is what we're finding each time, equals arc measure, which in this case is 44 degrees north, 33 degrees north, so 11 over 360 times 2 pi times 6,400. And we're going to go to our calculator. I'm just going to go straight to the calculator right away. 11 times 2 times pi times 6,400 divided by 360 equals approximately, and let's round to the nearest kilometer every time, 1,229 kilometers for part A. Part B, Pittsburgh, Pennsylvania is on the same north-south line as Panama City, which is 9 degrees north, so in Panama. Arc length equals, difference now is 31 degrees. 31 degrees between the two cities over 360 times 2 pi 6,400. Again, we're going to go straight to our calculator. Times pi 31 divided by 360. This time we get approximately 3,463 kilometers. Now, you might not know this, but this is true. Westford is due north of Acton. The center of Westford is due north of the center of Acton. These are the degrees of latitude for the two towns. So we have arc length equals, so let's subtract 42.5793 minus 42.4851 equals 0.0942 over 360 times 12,800, should have done that a while ago, pi, and we go straight to our calculator. 0.0942 times 12,800 times pi divided by 360 gives us approximately, this time I'm going to round to the nearest tenth because it's a much smaller distance, 10.5 kilometers. A little more than 10 kilometers between Westford and Acton. Maybe we should set up a 10K road race from Westford to Acton or Acton to Westford, or alternate each year. One year we go from Westford to Acton, the next year we go from Acton to Westford. Example 15. A rope is being wound around a drum with a radius of 0.8725 feet. So 0.8725 feet. How much rope will be wound around the drum when it's gone 39.72 degrees? You might be thinking, why do we care about something like this? Well, if you go into mechanical engineering, you care about these fine details of this gear is turning and this rope is winding around the gear, or this is the chain on a bicycle and it's turning here. How much bicycle chain goes around that gear when it's gone 39.72 degrees? And again, that might be important when you're designing something. So, arc length. Equals 39.72 over 360 times 2 pi times 0.8725, and we're going to go straight to our calculator. Approximately 39.72 times 2 times pi times 0.8725 divided by 360, and we have approximately 0.6049 feet of rope gets wound around the gear or the drum. That's example 15. Example 16, we have gears here. Two gears are adjusted so that smaller gear drives the larger gear. So this one is being turned by a motor, and this gear turns the other gear. So the motor drives this gear drives this gear. The two gears are adjusted so the smaller gear drives the larger one as shown in the diagram below. If the smaller gear rotates through 225 degrees, so it goes from 225 degrees, how many degrees has the larger gear gone? Well, it's not going to be 225 degrees because their radii are different. But the arc lengths that they travel will be the same. The arc length that this small gear travels will be the same as the arc length that this large gear travels. The degrees will not be the same. So, what arc length does this one travel? So, arc length of the small gear, S, equals 225 over 360 times 2 pi times radius 2.5 centimeters. So 2 times 2.5 is 5. 225 and 360. 0.625 times 5 pi. 3.125 pi centimeters. That's how far this first gear travels, the outer part of the first gear travels. Okay, 3.125 pi centimeters. The arc length of the second gear is going to be the exact same amount. Arc length of the larger gear is going to equal arc measure over 360 times 2 times pi times 4.8 is our radius. Arc length of the larger gear is the same as the arc length of the smaller gear. 3.125 pi equals arc measure over 360 times 4.8 times 2, 9.6 pi. Divide both sides by pi. The pi's are going to cancel. 3.125 times 360 divided by 9.6. Arc measure equals 3.125 times 360 divided by 9.6. Approximately 117.2 degrees. So probably ends up somewhere around here. This one goes all the way to about here. This one makes it to about there. Okay. Example 17. The figures show medicine wheel, a Native American structure in northern Wyoming. This circular structure is perhaps about 200 years old. There are 32 spokes in the wheel, all equally spaced. Okay, so that means that we can find the measure of the central angle between each of these in degrees, and then we're going to convert it into radians. Okay, so how do we do that? Well, 360 divided by 32. Equal to 11.25 degrees. How do we convert from degrees to radians? 11.25 times pi over 180. Going from degrees to radians, we multiply by pi over 180. 11.25 180, oops, times pi gives us approximately 0.2 radians. Yeah. About 0.2 radians. Let's keep it in terms of pi. Sorry. 11.25 divided by 180. 0.0625 pi radians. So about 11.25 degrees, or 0.0625 times pi radians. If the radius of the wheel is 76 feet, find the circumference. So circumference equals 2 pi r, 2 pi times 76. 76 times 2, 152 pi feet, or approximately, times pi, approximately 477.5 feet for the circumference. Find the length of each arc. So find this length, this length, this length, this length. So arc length equals arc measure 11.25 over 360 times circumference, which we just found, 152 pi feet. 11.2 times 11.25 divided by 360, and we get approximately 14.9 feet between each of the different stops around the outer portion of this Native American medicine wheel in northern Wyoming. Example 18. The tires of a racing bike are approximately 70 centimeters in diameter. How far does the bike travel if the tire makes 10 revolutions? We're going to round this to the nearest 100 centimeters. So that means that we're going to do 10 circumferences. Circumference equals d pi, since we're given diameter. Circumference equals 70 pi, and we're going to make 10 of those revolutions, so 700 pi centimeters, which is approximately equal to 700 times pi equals approximately 2,199.1 centimeters. And if we round that to the nearest 100 centimeters, so we're going to round this up to 2,200 centimeters. That's the answer to example 18. Thank you very much. Bye.